dura, see it? Dural tail. Look for these dural tails. That tells me it's attached to the dura. Another way I can show it is like this. Here's the brain, here's the dura, here's the edge of the dura. I'm pulling it back off the brain. As I pull the dura back, there's the tumor attached to the dura. Do you see where the tumor was? Do you see where it was? It was right in this space here. See the outline of where it was? It was right there. And then when you pull the dura, it just pops out. It doesn't invade it usually. It just pops out. Easy to resect them. So as long as you're healthy enough to do surgery and I can get to it, we can use you resect these. And again, if they invade the brain, you give it a higher grade, and that means it may recur, but it just usually pushes on it. So here's another example. Here's the dura. Here's the tumor coming from the dura, just pushing down on the brain, not invading it. Under the microscope, we want to look for those psammoma bodies, those whirling, oh, beautiful whirl. Looks like a cinnamon roll, that one there. We have these whirling calcifications. EMA is positive, and the tumor cells themselves are just bland spindle cells that are whirling. But forget that. I remember the psammoma bodies and the EMA. All right, now some other tumors that you should know. You should know about this one. And again, the reason you should know it is because it's incredibly bad. This is a very sad tumor. It's very young kids, and they die of it. Almost everyone dies. Okay, this is called atypical teratoid rhabdoid tumor, ATRT. What? ATRT. I know, it sounds like an at almost, right? So atypical teratoid rhabdoid tumor. Do you think it's going to have skeletal muscle differentiation? Does it look rhabdo, like skeletal? Yeah, it's going to have some cells that are kind of differentiating. It's an immature tumor, but it's some differentiation here. So this is a highly malignant, lethal tumor of very young kids, usually less than 5 at diagnosis, and they usually don't survive more than a year. It's by definition grade 4. It looks terrible under the microscope. It is very aggressive, lots of mitosis, lots of necrosis, very bad. Now, it has what's called divergent differentiation. It's going to have differentiation towards skeletal muscle. So you'll see these rhabdoid cells. So in other words, these tumor cells with big areas of cytoplasm, these big areas of cytoplasm. So here's a nucleus with this big red cytoplasm, and it's got processes. So this looks like a muscle. It's like a muscle cell. So they call them rhabdoid cells, kind of like those rhabdoid strap cells that you saw in rhabdomyosarcoma, those rhabdoid cells, very similar. Now, here's what I would ask. If I was going to ask one thing, I would ask, these tumors have deletions of the INI1 gene. Oh, I want an INI. I want an INI. No, you don't want an INI this time. You don't want an INI. INI1 gene mutations on chromosome 22 are highly associated. They're diagnostic of this tumor. So remember, ATRT, INI. Well, I'd love to be in and at. There's at-ats. No, I wouldn't, because at-ats always get killed. And always get the rebels always beat the at-ats. So I'm trying to make a mnemonic here. Help me. My Star Wars friends, help me. At, rhabdoid. I don't know. Red things. Red soldiers. I don't know. Red stormtroopers. INI. I want to be in and I'm trying to help you remember. I'm trying. You got to help me. If you come up with some association, let me know. Again, not very tested because this is very rare. Very rare tumor. It's like 200 cases a year. It's very rare. And then when it does occur, unfortunately, it's very lethal, very bad. All right, now, can you get lymphoma only in your brain? Primary lymphoma only in the brain? Sure, you can. You can. And it usually occurs in immunocompromised patients. In fact, it is the most common brain tumor in immunocompromised patients. So patients with AIDS, patients with immunosuppression from transplant, people who are immunocompromised, their most common brain tumor is going to be a lymphoma. Now, it's usually a diffuse large B cell, which is more aggressive. It's an aggressive tumor. Diffuse tumors are not listening. Large cell, these are bad. They're usually Epstein-Barr positive, usually EBV positive. Now, on CT or MRI, you'll see multiple ring-enhancing mass lesions. So if you remember, in AIDS patients, when I see multiple ring-enhancing masses, my differential is it toxoabscesses? Does the patient own a cat? Or is it high-grade, large cell, diffuse immunoblastic type lymphoma? Because they both multiple ring-enhancing masses. Well, toxo, it's usually more in basal ganglia. This is usually more diffusely spread throughout the brain. But the way you tell apart is treat. Treat for toxo for 2 weeks. If the masses get smaller, it's toxo. If they don't get small, you need a brain biopsy. And again, they usually die of it. So CNS lymphoma is usually a lethal thing, not a good thing to have. All right, now one more thing and we're done with the chapter. Do tumors of the brain, can they be involved with familial diseases? Can they run in families? Yes. There are familial tumor syndromes that can involve brain. So these are important to always remember. And this will be a nice review of some of the stuff we've done in the past. So do you remember Lee Fermini? Yeah, this is when you're born with a germline mutation in P53. P3, that's the guardian of the genome. Do you remember what it does? It tells RB to stop the cell at the G1S checkpoint. Then, if that doesn't work, it will tell Bax to punch a hole like an axe in the mitochondria. And who lets this cytochrome C out? Bax. So the cell will kill itself. So whenever there's a mutation, this is the guardian of the genome. So if we knock out P53, we're losing our guardian. So that's why it's associated with cancer, because I can't kill cells that are mutated now. So that's why you get cancer. So most malignant tumors have P3 knockout. So for Lee Fermini, you're going to get lots of malignant tumors. You're going to get breast cancer, colon cancer, sarcoma. Now for the brain, they usually get medulloblastomas. Lee Fermini. That's a very malignant tumor, isn't it? Yep, medulloblastoma. Okay, now Turcot's. This was a polyposis syndrome. So you get thousands of polyps and you get colon cancer because of all those polyps. You better do a colectomy. Now, this is the only one that was recessive, the only polyposis syndrome that's recessive, thank God, because that means it's rare. It's rare, and it's bad. I remember terrible Turcot's, because these APC mutations not only cause polyposis, but they're going to give you a terrible turban tumor, a brain tumor. You're going to get either medulloblastoma, which are very malignant, or glioblastoma, which are even more malignant. So terrible Turcot's, it's terrible because you get malignant glial tumors like glioblastoma or medulloblastoma. Bad. All right, now Gorlin syndrome was hereditary basal cell syndrome. So when you have patch mutations, now Sonic the Hedgehog pathway is on, and the basal cells of the hair follicle grow. So Sonic the Hedgehog mutation in pathway is going to lead to basal cell carcinoma running in your family. But they're also going to get medulloblastoma. So notice all these medulloblastoma. All right, now tuberous sclerosis complex. To get it, you have to mutate either one of tuberous sclerosis complex 1 gene or tuberous sclerosis 2 gene. This one was for Hamerton protein. Hamerton, that makes sense because they get hamartomas everywhere. And this was for tuberin protein. Hamerin and tuberin. Those are the two proteins that form a complex. So if I mutate either one, the complex doesn't work, and you get hamartomas. So you're going to get cortical tubers in the brain, which is a hamartoma of your brain. Hamartoma. Now, they're usually next to the ventricle. They're under the ventricle. So over time, they can push out on the ventricle and create these little candle wax dripping. They call it guttering, candle guttering, little bumps there because they're right next to the ventricle. But unfortunately, this proliferation could turn to a tumor. It could turn to a subependymal giant cell astrocytoma. Yeah, you don't see these very often. These are it's like a buzzword for tuberous sclerosis. These are grade 1 astrocytomas. That's good. And they're next to the ventricle. So therefore, they're under the ependymal cells. They push on the ventricle. They will present with obstructive non-communicating hydrocephalus. So I want you to remember lateral ventricle mass presenting with hydrocephalus in a patient who's got rhabdomyomas, ash leaf spots. Yeah, ash leaf, Sjogren's. Do you remember angiofibromas in the face? That's when you're going to think tuberous sclerosis. They love tuberous sclerosis. The angiofibromas, the ash leaf, the Sjogren's patches, very testable. All right, now the next tumor associated with familial is von Hippel-Lindau. They were born with a germline mutation in VHL, so they get 3 tumors because it's on chromosome 3P. So you're going to look for renal cell carcinomas. You're going to look for heme angioblastomas, usually in the cerebellum, brainstem, and spinal cord. And you're going to look for pheochromocytomas. They also get lots of cysts, but that's not 3 letters. I don't know how to make it 3 letters, but nobody died of a cyst anyway. So they get lots of cysts as well. But remember this heme angioblastoma, there's cystic mass in the cerebellum, and they love to make erythropoietin. So cystic mass in the cerebellum, that sounds like a polycytic astrocytoma, doesn't it? Sounds like a polycytic, except they got high EPO, they got polycythemia. Oh, that's when you got to think about this. That's a blood vessel tumor. All right, last one was neurofibromatosis. There were 2 types. We had type 1 called von Recklinghausen. Wow, how many letters in von Recklinghausen? 17. So this is on chromosome 17, and it made a protein called neurofibromin. Do you remember it was supposed to turn off RAS? It's supposed to turn off the oncogene RAS. If you don't turn off RAS, you get tumors. So you're going to get neurofibromas. You're going to get cafe-au-lait, usually over nerve trunks, so you get axillary freckling from the cafe-au-lait. You'll get Lisch nodules, hamartomas in the iris. But what you'll also get are gliomas of the optic nerve. So that's a polycytic astrocytoma of your optic nerve. Well, so you're going to be able to usually be able to resect that, but you may lose vision. They can also get pheochromocytomas as well. So NF1, pheos, and optic gliomas. Now for NF2, chromosome 22, mysterious protein called Merlin. We don't know what it did. Well, actually, now we do. It's for contact inhibition of growth. When cells grow, they hit each other. Merlin says stop growing. When you mutate NF2 and Merlin, now they grow over each other and you get tumors. Now, 2 tumors in the head, schwannomas, acoustic vestibular schwannomas. Anybody can get one. If they're bilateral, it's always genetic. Okay, genetic could be unilateral or bilateral. If it's bilateral, it's always genetic. Now, they also get another tumor. They get the meningiomas. So schwannomas and meningiomas, 2 tumors in the brain. Now, in the spinal cord, we talked about ependymomas. Spinal cord ependymomas, that's lower yield. That'll be for gunners. Gunner level students, which you are. We did it! Boom, boom, boom! We did it! We completed pathology. What an amazing adventure. What a ride. Thank you for sharing this adventure with me. I've had so much fun teaching you guys and testing you and quizzing you and singing songs for you. I hope you really, really enjoyed it, and I hope I'll get to see you guys on the wards. I hope I get the chance to come to Terre Haute soon, because I can't wait to see it. Maybe for next year's awards dinner, I'll get the chance to see you guys, because I really want to meet you in person. I feel like I know some of you because of all of our lectures and Facebook, watching your pictures on Facebook. So I've kind of like been stalking you. I've been living vicariously through you, seeing all your adventures there. But I wish you guys the absolute best of luck. Remember, your destiny is greatness. It's your destiny. You're going to help millions of people throughout your lifetime, because you don't just help the patient, you help their family too. So millions of people are going to be impacted because you studied so hard, because you can be the best doctor you can be, because you have a great heart. People will be cured. People will be treated properly and be healthy. They'll see their daughter graduate. They'll see their son get married. That's what life's about. And you're going to make a big difference in people's lives. And you got a great heart. I can see it. I can feel you. I can see you. So your destiny is greatness. I want you to live out that destiny. So study as hard as you can, get on the wards, and have a great time. And remember me. Remember me. Yeah, when you come to LA, come on out, right? You come to Florida, come on out, and I'll get a chance to see you, and we can go see celebrities, go stalk them, have a good time. I still have all my connections in LA. Go stalk celebrities. All right, so I wish you guys the best of luck, and I will definitely keep in touch. You got my email. You have questions as you're studying, let me know. I'm here for you guys. And in the future, I'll have a bunch of students who send me emails on 3rd and 4th year asking about things, and I can try to help you there as well. I want you guys to be successful. All right, so thanks again for hanging out with me on this ride. I really